Number 7, label the types of continuity for the following. First, part A has the function x to the power 6 minus x cubed. Now remember, each function by default is going to be x as an element of all reals without any breaks unless one of the following happens. Remember, we've had something to do with the square root. If you have a square root, let's just say that x, a square root cannot have negative numbers. So that would mess up and have a break. Square root cannot have negatives. Or if you have division, that would be another break. Cannot divide by 0. Finally, one other type of break would be like piecewise. So piecewise functions could have a jump type discontinuity. So piecewise could have jump or removable, something like that. So piecewise, it's kind of just up in the air. You got to look at it to see what exactly is going on. This one does not have any division. It's not piecewise. There's no square root. So since it's all reals, there's no breaks here. So this is continuous. This first one is continuous. Let me write that in a different color. We can see better. And you could graph this, which I guess I can do so, but x to the 6th minus x cubed, x to the 6th. What did I do here? X. I'm sorry. Let me try this one more time. X to the 6th minus x cubed. Here's your graph. You could zoom out, and you would still see that, in fact, it is continuous. So that one's continuous. And I can take this picture if I want and add it later. Okay, now let's go on to the next graph here. We have division here. So this will not be continuous because we know we cannot divide by 0. So if I set it equal to 0 here, I could find out that x, really it's not allowed to equal 0. X could not equal -5 if you saw that. That's infinitely a problem. It doesn't cancel, it doesn't get rid of it. We have an infinite discontinuity. When x equals 5, because you're not allowed to divide by 0. And so this will look like the graph will be going to infinity. So I'll go back to my graph here. And the equation was, let's get this out of there, 3 over x, and I forget if it's minus or plus, x plus 5. X plus 5. And you can see there's our graph right there. And when I show the picture down here, we do in fact find out that it cannot equal -5, just like we were saying earlier. I'm sorry. This graph cannot equal -5. I can shrink it to show you right here. At -5, we have problems. Okay. All right, part C. Here's piecewise. And to find out real quickly, you can plug in -2. I have -2 minus 3 more is -5. That gives me -5. And then on this piece of the piecewise, when I plug in -2, -2 squared is 4, because -2 times -2 is positive. Positive 4 minus 1 is 1. These are different values. We can see this will be a jump discontinuity, because the values are jumping from one place to another. X equals -2. And so again, we can come over and look at the graph. And so if I wanted to graph this one, the way you do so is you press the button next to 9. Here I click piecewise. I have two functions. The first value was x minus 3. And this is when x is less than 2. Less than -2 rather. And then we had x squared minus 3 when x is greater than or equal to 2. Not 2, I'm sorry, negative 2. And so we can see here that this is, in fact, also a jump. And finally, the last one, we come here, and we're not allowed to equal 0 in the denominator, which can make us think this is going to be infinite. But if we notice this is a difference of squares, we can factor this, and you can ask yourself, what term am I missing? The A term, the B term, or the C term? I'm missing the B term, so I have a 0x I can throw in there. So if I have to factor this, I'm missing that B term. It's the same thing as factoring x squared plus 0x minus 81. And so if you check out the x method, you might notice it's difference of squares, like I said, and know how to jump with the square root method, how to get your values. But here I'm looking for factors of negative 81 that add up to 0. That's going to be 9 and negative 9. So I take my A term here, I split it, and so I'll have x plus 9. When I say split it, I meant split the power. Times x minus 9. All this is over x plus 9. This is my new equation for f of x. Notice these two cancel out, or better mathematical word, I remove those two, so it's removable discontinuity. Now the part I removed, if I solved for x, that'd be when x equals negative 9. Now if you graph that, you wouldn't see it on the graph, but where it would come up is on the table. So I'll go here and I'll graph this. X squared minus 81 over x plus 9. You'll see that this has a removable discontinuity, though you can't see it here. If I went Control T at 9, I'm sorry, not 9. It's at negative 9. I'm going the wrong way. At negative 9, or undefined. So when x is negative 9 over here, you couldn't see this, but it was actually removable down there. So